Hello everyone. Greeting of the day. Myself Nitish Kumar. Hereby, I am presenting for the paper titled as Fine Grained Classification of Skin Cancer Types using Deep Neural Network on Medical Images, and I am the one of the author of this paper. So before going to present about in this paper, I want to introduce why we should work on these topics and all. So, why it's breaking? Yeah. So, if you see the data from the World Health Organization and Skin Cancer Foundation, then in the year 2020, when the COVID was there, so if we the total death in that year only, it was 10 million plus due to cancer, and among them, the 1.2 million death due to skin cancer only. And according to the Skin Cancer Foundation, the 20% of Americans will be get affected by the skin cancer in their whole lifetime. And if we talk about the skin cancer classes, then globally there are various classes of the skin cancer. If we malignant, benign, BCC, BKL, AK, IEC, there are some other classes also. But the main focus of ours here is to classify it in between the fine grained classification. And we are focusing on the three classes. Those are malignant, we also call as melanoma, and basal cell carcinoma, that is BCC, and benign keratinocytic lesion, that is BKL. And if we see the data set of these classes, and then that is the dermatoscopic images, then the images of these classes, it looks very similar, and that we can see in the next slide also. See, if we can see the malignant basal cell carcinoma and BKL, in the all three classes, the images are very similar. Even like if we want to try, if we're trying to identify from the nagged eye, we can't identify, because like if you can see like this image, and like this image, all three look like similar. So like whenever when we are building the CNN for the classification model and all that, in those cases also, like normal model can't identify in between the fine grained classes. So our main focus is to classify in between the fine grained classification, fine grained classes only. So now there are some existing method right now for the cancer classification, but they are mainly focuses on the global class classification, not the fine grained classification. In the case of global class classification also, the currently system that using in the hospital and all over the world is CAD, computer aided diagnosis. In that right now, the most of the places, they are only classifying between the two classes, benign and malignant, but there are more classes of the skin cancer. So now the thing is that if we have the multiple classes, and there are in that for every classes, if you have some skin cancer types, in that case there are the what I can say, there are the years by which you can die. It will be different for each classes. So if you are simply classifying it between benign and malignant, so it is not the okay things. Like people are dying by these things only. So now let's see the people that the classification model and pre-processing techniques that the people are using right now. So the main whole process of the classifying the skin cancer is first taking the dermatoscopic images, then they are applying also some pre-processing techniques to, like, let's say, enhance the images and removal of hair and all that, and then building the CNN classification model using the CNN. And most of them are right now classifying in between the two classes, three classes, and all that. And they are also classifying in between the global class classification, not fine grained classification. And the classification model used till now is the EfficientNet V1, MobileNet. Some model also is a semi-supervised, then some Inception V3, ResNet 50, ResNet 101, and all that. And then VGG, that's on the simply VGG, simply CNN. Now, what we are proposing for the classifying the fine grained classes of the skin cancer is we are just taking the dermatoscopic images, and we are building classification model using the CNN only. But our model should be able to classify in between the fine grained also, along with the global class classification. So our focus is to the classify in between the fine grained classes. And we are building right now here three model, and will be first model will be using from the some reference paper, and then model 2 and model 3 we are building. So if we talk about the data set that we are using, so for the data set we are using the uh, ham 10,000 data set. That's from the Harvard Dataverse, and it's the open data set. From there we are directly taking the malignant and BKL classes. But for the BCC, we are taking 80% of data from the ham 10,000, and from the for the 20% of the data we are using other sources. And for the labeling of these data set, the Harvard Dataverse or ham 10,000 data set, what they did, they are taking experts from the hospitals, and they are very experienced in these field. And they also doing for the confirmation, they are also using histopathology and all that. So now the things from where these data set were taken, the location and like gender, these things. So if you see the data set count, malignant has total around 1,000 plus, BKL has also some around 1,000, and BCC has around 700. And these data set are taken from the both male, female, and mixed gender. Now, if we talk about the from which part of the body it taken, so see, most of the data is major data set from taken from the back, face, lower extremity, and upper extremity, and also taken from the chest, trunk, and all the places of the all the part of the our body. And then if we talk about the this data set contains the which age group of the people. So it mostly, if you see the here the graph, the major of the data set is taken from the around 45 to 75 age group, but yeah, it also taken from the other age group also. Now if we talk about the our base model, that is we called as model 1, we taken from the reference paper that given below. So in this there are after the input layer there are 6 hidden layer, and after that there is a flattened dense and softmax output layer. And in the each hidden layer there is con block using the review nonlinear activation function, then bias normalization, then pooling layer, and that using max pooling, and then some dropout. And also in each hidden layer the dropout probability is different. And along with that, to avoid the vanishing gradient problem in the deep neural network, we are also in the base model only, we are also using the escape connection from the third layer to the directly before flattened layer, and we are then after we are concatenating both and then giving to the flattened layer. Now using this base model, the result shows as the for the class BCC, the F1 score is 73, for the BKL is 70, and malignant has 75. If we talk about the accuracy is like come in 72, and similarly the macro average and weighted average accuracy. Now it comes to right now we are working on the fine grain classification. So in the fine grain classification, we can't simply work on the like just taking the features from the final layer and all that, and just taking from the escape connection. For the fine grain classification, along with the important feature, we have to also consider the some minute feature that only the difference between the what I can say fine grain images. Let's say the BCC and BKL that we saw the image in the starting, the images is very similar, but there is some minute difference that we have to capture. And for capturing those, we have to take the features from the starting of the layer also. That's why we are taking some feature from the layer uh, first hidden layer, and then we are concatenating with the before flattening layer. We are concatenating with the final feature. And in this way they basically the model is trying to predict the main feature also, and some minute feature also, so that it can classify very easily in the fine grain classification. Now if we compare the our result from the base model and the model that we are our model 2, that also considering the some minute feature from the layer first. So in this case, if we can see that directly, if we focus on the accuracy, then previously it was 72 for the model 1, and that also written rate part is for the model 1. So and it's increasing to 73, 73, and 73. Yeah, in the weighted average case, it's not increasing, but other macro average and accuracy part, it's increasing. going from 72 to 73. Now, the major concern is like, yeah, we consider the final feature also and some minute feature also from the first layer. But the thing is, the receptive field of the images and the features in every layer is getting changed. So we were just experimenting like what the thing, how the things will work if we also considering from the just a second layer. So if we are considering from the some features from the first layer also, first hidden layer also, second hidden layer also, and the final some important features also, and then combining all the features, concatenating all the features, and then sending it to the flattened layer, then dense layer, then output layer. And then in this way, basically what is happening that in this case, we are also considering along with the important feature and some minute feature, we are also considering some intermediate feature, so that like when it's look like the some let's say we are doing some average of things and all that, it's look like that we are also considering some intermediate feature to classify the fine grained classes. Now in this case, if we consider the compare the result of this with the previous model, that is our model 2, then accuracy is getting increased from 73 to 74, and in the case of micro average accuracy, it's getting increased from 73 to 75, and for weighted average also here getting increased from 73 to 74. So like overall, like in our case, when we are considering all the important features, some minute feature and some intermediate feature, then in that case the fine grained classifier is getting more robust. If we can, if you see the our combined model, basically here we are presenting the all the three model together. So like accordingly, if you can see the in the case of model 1, we'll just using these this one. In the case of model 2, we will using this, and then in the case of model 3, we will be using this connection. So it will be concatenating all the three and giving the output. Now the what we are concluding from this, and what will be the our some future work and all that, so that we can make this model more robust and we can easily classify the fine grained skin cancers, and we can save the lives of the people. So now the major of course the major concern in the when we are using CNN is the vanishing gradient descent, and of course in that case the escape connection will always help. And for the fine grained classification, early feature, that is minute feature, and intermediate feature, it helps. And yeah, that's it for now.